This lesson is on the inverse tangent function. And before we go any further, let's look at the tangent function's domain and range. Domain is all reals, but x equals pi over 2 plus k pi, where k is an integer. Why are there restrictions at pi over 2 plus k pi again? Well, let's just remember a couple of things. One, if I was to draw a unit circle and I was at the location of pi over 2, I would have coordinates of 0, 1. And since tangent at pi over 2 is the same as sine of pi over 2 divided by cosine of pi over 2, I would have 1 divided by 0, and that's undefined, which is why we have ourselves a lousy drawn vertical asymptote. And this keeps repeating, not just at pi over 2, but 3 pi over 2 and 5 pi over 2 and 7 pi over 2 and 9 pi over 2. You get the idea. It also goes backwards. You can go back negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. So that's the restrictions and why you can't include all reals. But when it comes to the range, you have to remember one more time, let's draw this out, that tangent is also the slopes of these lines that go through the origin at these angles. And so technically you can have very small slopes that are just above 0 and maybe below 0 or including 0. And you can have very steep slopes, which with this graph is a very lousy drawn design, but you get the idea. So essentially the range says any slope is possible. So what we're going to do is we're going to restrict the domain similar to what we did with cosine. Let's start at 0. We're going to go to pi, and this looks pretty good, but if I was to apply the horizontal line test to this, it would pass. I have to be careful on the endpoints, because if I include both endpoints, then 0 and pi would force it to fail, and therefore the inverse would not be a function. To be realistically, that's not my bigger concern. My bigger concern is this point of discontinuity at pi over 2, thanks to our asymptote and our undefined tangent. So if I would like to have it to be one continuous graph, let's change it to the settings that were our sines restrictions. Let's have it go from negative pi over 2 to pi over 2, and you'll see now that not only will this graph pass the horizontal line test, but it will constantly be continuous throughout. So I think we've got our proper restrictions. So let's take a look at what this reflection would look like as a tangent inverse. I will notice that because I have a tangent inverse, this is no longer angles, so maybe the best thing we could do here is change our x-axis to something that would be more ratio-like ones. Let's change our angles to pi over 2 for our y markings. This looks pretty good. If I recall, let's start writing this down, that since I have y equals tangent inverse of x, my domain are my ratios, and my ratios are represents all the possible slopes. And since there's all possible slopes, I can say it goes from negative infinity to infinity. Since my range is now being restricted and it goes no lower than negative pi over 2, I don't actually include it because, remember before, there was no defined value. I shouldn't expect a value at pi over 2 either, so I won't include that. So this is my domain and my range. I do definitely see a point of symmetry right here at the origin. So since it's symmetric with respect to the origin, I can say this is an odd function. So we know that tangent inverse is an odd function. And I also know that I had vertical asymptotes for a tangent function, so I think it only makes sense that now I can draw in horizontal asymptotes at pi over 2. And so unfortunately I have to, now that you've seen them, they have to go bye-bye so that I can draw over here, and that would mean that my asymptotes occur at y equals both plus or minus pi over 2. And there it is, the inverse tangent function.